Section 6.9. Calculating the equilibrium partial pressures in a mixture of ideal gases. Here's one example. The decomposition of chlorine molecule generates two chlorine atoms. Assuming both chlorine 2 and chlorine are ideal gases. And then we assume the initial number of moles of chlorine 2 is naught. There's no chlorine atom at the beginning of the reaction. Let's say at equilibrium, assume this Xi mole of chlorine 2 is decomposed to produce 2 times Xi mole of chlorine. And then the total number of moles of the gases is this. Over here, this part is the number of moles of chlorine 2. This is the number of moles of chlorine atoms. Therefore, we have N0 plus Xi mole of gases. The final pressure of chlorine 2 is the total pressure times the mole fraction. On top, this is the mole of chlorine 2. This is the total number of moles on the bottom. Similarly, the final pressure of the chlorine atoms is the total pressure P times the mole fraction of the chlorine atoms. On top, 2 Xi is the number of moles of the chlorine atoms. On the bottom, this is the total number of moles. And then assume we know the equilibrium constant. How do we get this? Well, if somehow we can look up the Gibbs energy of formation of chlorine 2 and chlorine, we can use this equation to compute the equilibrium constant at temperature T. So if we have this equilibrium constant K sub P, we can use this equation to compute the partial pressure of chlorine and chlorine 2. We plug in the expression of P of chlorine atom and P of chlorine 2 here and here. Remember, there's a coefficient in front of the chlorine atoms. So therefore, we need to put this coefficient here. After we plug it in, it looks very complicated. However, we can clean it up. This is simple algebra. After we clean it up, we have this equation. We have this K sub P. This is the equilibrium constant. We know this by using the Gibbs energy of formation of chlorine 2 and chlorine. And then, assuming we know the equilibrium pressure. All right, so if we know this equilibrium pressure, and if we know N0, that's the initial number of moles of chlorine 2, then we can easily calculate the value of Xi. After getting this Xi, we can just calculate the number of moles of the chlorine atoms, the number of moles of this chlorine 2 molecules, and also we will be able to compute the equilibrium pressure of chlorine 2 and the equilibrium pressure of the chlorine atoms.